Hello, my name is Tom Casey, and this is my final presentation for CIT260. Please excuse the scratchiness in my voice as I am still recovering from what can be known by anything but the plague from 2 weeks ago. Static versus instance variables. A static variable is associated with the class, not objects. So it has one copy per class, and the keyword static defines a variable, i.e. public static, you'll see in the statement. It is essentially a global variable as it can be shared. It is accessed without creating any objects of its class. Now, an instance or a non-static variable is associated with objects or instances rather than a class. It is instance specific and is not shared among instances. It is defined without the keyword static. Here in this upper example, you'll see the non-static or instance variable. So you can see this is information that will be only in, this variable will only be in this instance. You'll see it's pulling in information from the keyboard. There's a double and there's a Boolean. This variable will be only used here in this portion of the code. Whereas down here in the static variable, you see note public static. So static indicates it is a static variable. And down here, you'll see the class name followed by the dot operator. This is creating a variable that can then be used throughout other areas of the code. Array and an array list. Arrays are fixed lists that may contain either primitive values, byte, short, integer, etc., or objects created from classes. Arrays are limited as they must be of the same data type. So you can't mix integers with characters and such. You need to have the same object. They need to be of the same data type. Arrays allow you to dynamically change or modify the items in the list. The elements in the list have an index position. The index is an integer value indicating the relative offset of the element from the start of the list. An array list is a class that allows you to create variable length lists of objects. The advantage of an array list is that it is a dynamic list that is not in fixed length. So it can be of any length. It can also contain different data types. Here's where you can pull in information and you can have the integer and you can have the Boolean, you can have the character and so forth. Although primitive values cannot be placed directly into the array list, they can be converted to an object and then placed in the list. Here's an example of an array. Here you'll see this is a fixed length list. Each item has its location in memory. This list will always be the same length. The information here may change, whether it's the amount of grain, let's say, or the price of the grain. But the grain is always going to be part of the list. It's always part of your inventory. You just may not have it in your inventory, but it is always there. As with an array list, you'll see here, we're building this list from another array. We're pulling in this data, pulling in the list of scenes, their name, the symbol that they use in memory, the distance from Naboo. We're going to go down here, we're going to pull this into an array list. And this array list will then, called locations, this will give us a list that we can use. And we can always, this is not a finite list, so we can go back, we can add numerous scenes or remove scenes. And then when this code is run, it's still going to create the array list. And it's not worried about how many items are in the list. Character stream and byte stream. In Java, byte streams are used to perform input and output of 8-bit bytes. A very common use for a byte stream would be the input and output of files, file input stream, and file output stream. This is not the recommended way. Character streams are what are recommended within Java. They perform input and output utilizing 16-bit Unicode. So they work faster there, and they also use file input stream and file output stream for file reader and file writer. but doing so at 2 bytes at a time provides a faster output, especially for large query results. For and for each loops. The for loop provides a concise way of writing the loop structure. The for statement consumes the initialization, condition, and increment or decrement in one line, thereby providing a shorter, easy to debug structure of looping versus the while loop. This is a good way to collect data from an array or array list for use in different types of output or input. The for each loop is another array traversing technique like the for loop and the while loop. It starts with the keyword for, like a normal for loop, but instead of declaring and initializing a loop counter variable, you declare a variable that is the same type as the base type of the array. In the loop body, you can use the loop variable you created rather than using an indexed array element. This is commonly used to iterate over an array or an array list. Here's an example of the for loop. As you can see, it's very concise. We set the integer information here, and then we just churn through the loop until we get the information we need for our trail stop. We match up our milepost, and we can indicate where we're located at, and that's what the loop is for. The for each loop here, as you can see, we set the information up top, and then this is to get the health. So this loop, we set the information up top, we set it to 0, and it's going to grab the health of the actor and provide that. When it provides that, it stops. File content creation. File content creation is very important within code because it gives you the ability to output information, whether it be saving the game to a file, or downloading the data into a file, or just presenting it on a screen, but you need to be able to grab that file content. Here, you see this is where we are creating the file content for however we're going to either present on the screen or place it into a file. This is for our scenes, and so here we have the for loop that we continue to go through, and we churn through this, gathering this information here that will fall under these titles. Excuse me, that will fall under these titles, and then it'll be ready to be presented. Now here is where we present the data, and this is where we can present it to the screen right here. As you can see, we created titles, a name, symbol, distance from Nauvoo. We have underlines to underline those. And then the information will be listed underneath. Get name, is your map symbol, get distance from Nauvoo. These will be listed underneath these in these columns as indicated. And down here is how we export the scenes to a file. This gives us the ability to print it to a file name. We'll be asked what, it asks you to save it to the file, and we give it the file name, and it saves it, and then it presents us with your file was successfully saved. If it's unable to do so, then it'll present us a message. Exception handling. Exception handling is very important because if a game has an error, we don't want the game to stop right where it is. We want it to be able to trickle up and to be able to present a meaningful error to the user so they can understand where the error occurred. This also works well for the coder, especially if you're working on someone else's code and you want to have the ability to understand why an error happened and where it could have started from. So here we have our exception handling. We come through here, this is for saving the game, and it's going to do is going to say, hey, I want to save this game, and I'm going to try to write this out to this location. It says, hey, I can't write it to this location. It's going to catch the exception down here, and then it's going to push this exception up through game control exception, and then up into our view. So we'll be able to see what the exception is rather than just hard stopping and not giving us any indication except for an error. Now I'm going to demonstrate the program. And what we'll do here is pull it up right here. Here, I've already got it somewhat started. I just hit play. So I'm going to log in. I'm going to be Bob today. Today, Bob and I, we're going to go ahead And we're going to go ahead and start a new game. So N to start new game. And then let's go ahead and go into this team statistics here. So T for team statistics. And let's look at everybody's health. So I'll go into the health here. And here, you can see everybody's health at this current time in the game. So let's go ahead and let's look at their names. And here we can see the names of all the users. We had those listed up top, but now we also have that information here. So let's go ahead and go back. And let's go ahead and we'll save this game. So I'm going to go back one more. I'm going to go ahead and I'm going to save this game. So save. And it says, would I like to save the game? Well, yes, I would. Thank you very much. And now the game is saved. If you note, it was saved to filepath.dat right here. So now let's go ahead and let's load that saved game. L for load saved game. Like to load it? Sure. It's the only game we have loaded, saved, so that's the one it pulled up. So now let's go ahead and let's print the scenes to the screen. So we'll go in here and R, print scenes. And here you have right here the list of scenes, the name, the symbol, distance from Nauvoo. And here's the list of them in order from Nauvoo down to Salt Lake Valley. I'd like to thank you for listening to my presentation. I hope you are informed and better understand our program and Java in general. And thank you and have a nice day.